Hey everyone, let's take a look at number 9 in section 5.8. We're to calculate the following definite integral. Again, your numbers in the problem you're working on might be slightly different, but should be very similar. Turns out when we're going to use change of variables as substitution here. When we do, we're actually going to end up with this integral form, which you should remember evaluates as the inverse tangent function. So what I'm going to do is actually let u be e to the 3x. And the reason I'm going to do that is, first of all, note that if I square u, e to the 3x squared, remember we multiply the exponents, so I get e to the 6x. So this becomes 1 plus u squared. That's good for that form. And then also further, the derivative, when I take the derivative of e to the 3x, it's a chain rule. We have the derivative of the outer function e to the 3x times the derivative of the inner function 3x, which is 3, gives me 3 e to the 3x. So du is 3 e to the 3x dx. Now I've got an e to the 3x dx up top. That's great. Just multiply both sides by 1/3. And we have everything covered in our integrand. We do want to change limits of integration. So a little tricky here. X, the lower limit, is negative the natural log of 3. So what would u be? It's e to the negative 3 natural log of 3, right? So 3 times negative natural log of 3 is negative 3 natural log of 3. And now by a property of logarithms that we use quite a bit, in other words, the natural log of a to some power n is the same as n times the natural log of a, right? Remember, logarithms are exponents, and so we have this property. And so really I'm going in reverse. I'm going to take the negative 3, which is in front of the logarithm, and bring it up as the exponent on 3. And now what is e to the natural log of this expression? Well, it's just this expression, right? These cancel each other out. Or to think about it, right, the logarithm of this quantity, that's the power of e needed to get this quantity. So if I raise e to that power, I'm going to get that quantity, which is 3 to the negative third power. That's 1 over 3 cubed, which is 1/27. So a little tricky on that calculation. That's our new lower limit. The upper limit is 0 when x is 0. Plug in 0 there, I get e to the 0, which is just 1. That's easy. So lower limit is 1/27th, upper limit is 1. And then I have up top e to the 3x dx, so that's 1/3 du. I'm going to pull that 1/3 out. There's my du. And in the bottom, 1 plus e to the 6x, e to the 6x, right, is u squared. So that's 1 plus u squared. There's my new limits of integration. And as we said, that integral there, the antiderivative, is the arctangent function. And so I'm going to evaluate it at 1 and evaluate it at 1/27th. Of course, the arctangent of 1 is pi fourths, since tangent of pi fourths is 1. Don't know what this exact value is, and so I'm going to leave it in that form. So if you read the parentheses of a lot of these problems, read it very carefully. It'll say to give answers in exact or fraction form and use symbolic notation where necessary. And so it's necessary to leave it in that form. So this is the answer we're looking for in this case. Okay, I hope that is helpful.